So what happens in the case of frequency stability means, normally there will be, suppose the tolerance range in for what frequency stability is normally 1%. That means if you are using a 50 Hz supply, then the tolerance range will be 49.5 Hz to 50.5 Hz. Okay, so this much variation can be acceptable in the case of a frequency stability. And the third one, which is very important, which is nothing but, my dear, angular stability. Angular stability. Angular stability is dealt with, actually there are three types of stability. First one, steady state stability. Steady state stability. Steady state stability is nothing but, my dear, that means the stability of the system when we are giving a small disturbance. The stability of the system when we are giving small disturbance is called the steady state stability. For small disturbance. For small disturbance, what will be the stability of the system? It is called the steady state stability. And how can we find the steady state stability means, there is a tool or there is an equation for finding the steady state stability, which is known as the swing equation. These things will be later, we will discuss very detailed. This is just as an introduction, you take it as just as an introduction. Okay, next stability is that means the second stability is nothing but the second stability, means the subdivision, that is second stability is the transient stability. And transient stability is nothing but, my dear, stability of a system when large disturbance given. These one words are very important, my dear. Directly you can expect this type of questions in the exam. For small stability, what type of stability it is? For small disturbance, it is the steady state stability. What tool is, or what is used to find the steady state stability? Swing equation. These wordings are very important. These wordings are very important. Okay, note it down. And see, okay, large disturbance, these wordings are very important, my dear. And for finding the transient stability, we are using a tool, or we are using a method called the equal area criteria. These wordings are also very important. Okay, directly you can expect this question. For finding the transient stability, what type of tool is used, or equal angle criteria is used to find steady state stability, transient stability, or dynamic stability? Options may be like this. You can directly tick. It is for transient stability. So transient stability is nothing but, it is like an example of, see, lightning is a type of transient stability. Sudden switching on or switching off a device is a type of transient stability, because it's a large disturbance. Sudden short circuiting of transmission line, it is a very big disturbance. Sudden open circuit of a line is a large disturbance. So that all comes under the transient stability. And steady state stability, what will be the equation means, simply you switch on your AC in your home. No, the light will be for a short time, it will dim and it will okay. No? That is a steady state limit. It is a small disturbance and it will overcome within very fraction of seconds. See, that is a type of steady state stability. So this is what equal area criteria. So tool used to find the steady state transient stability is nothing but the equal area criteria. And third one is nothing but dynamic stability. Dynamic stability. This stability is nothing but, my dear, that means small disturbance appears periodically. So a small disturbance appears is called the steady state stability, steady state stability limit. So that steady state problem limit, that steady state stability, that will appear for a consecutive cycle, for 3 cycle or for 4 cycle or 5 cycle, up to 5 cycles. If this that small disturbance is occurring after for 2-3 cycles, steady state, or simply the small disturbance occurring for 3-2 cycles or 3-4 cycles, then it is called the dynamic stability. That means small disturbance appears periodically, then it is called the dynamic stability. So the first two things, that is angular stability and steady state stability, it's very important. Transient stability is very, very important. Dynamic stability is not that much important, because once you have the knowledge of steady state stability, that means a small disturbance occur for very few time interval, that is called the steady state stability. Along or expand that idea to for cycles, you will get the dynamic stability. So dynamic stability normally we are not dealing that much especially in competitive examination or in theoretical examination in university. We are not dealing that much with the dynamic stability, or we are not focusing that much with the dynamic stability, but we are giving focus to these two, that is steady state stability and transient stability. Okay, so now we will switch to what? Angular stability. Especially we are focusing on what? Angular stability. Okay, so for next class onward we will look deep into these three. Steady state, transient, and that angular stability concern. Okay, so thank you.